we're testing if the bolt is safe from the user, who may have a static charge on their body when they touch the bolt. And if the static zap happens, we want to make sure the bolt is protected from that. And there's a standard for that. We're using IEC 61004-2 as our guide. And that calls for level 4 testing, which is a test pulse at 15 kV near the bolt on a horizontal coupling plane. So we have our official horizontal coupling plane, which is a conductive sheet, and that's connected to ground with the official ground strap with two 470 kilo ohm resistors in series. That provides a little bit of a slower discharge, so that when we pulse the plate, the energy stays near the bolt for a longer amount of time. The rise time on the pulses from the ESD gun are in the nanosecond range, and so we want to make sure that the charge builds up on the plate before it dissipates into ground. So the test calls for those resistors in series to prolong the amount of field that the bolt sees. So the test calls for zapping the plate at various points around the edge near the bolt, and also attempting to discharge on the bolt itself. So we have our ESD gun, which applies 15 kV in the positive and negative direction with alternate polarity, and we're going to give it 10 test pulses at various points on the edge of the plate and near the bolt. Now the goal of the test is to make sure the bolt survives the test with no loss of memory. So we have a live connection to the bolt right now. We can see we're running one channel of voltage into channel 1 to power the bolt. The other two channels are grounded, so we can see if we have any ESD influence on the measurement. And so we're using Wi-Fi to connect the bolt to ProVision here. So I'm going to apply test pulses on the edge of the plate. You can see and hear the pulse. And as I approach the plate, the arc finally jumps the distance and discharges. Now I'm going to attempt to pulse the bolt itself, but the bolt is so well insulated that it's not really possible to get a 15 kV pulse to go all the way inside the electronics of the bolt. We can pulse around the voltage conductors, and here it's really just jumping around the surface of the insulation and then hitting the plate. And we can see that our count up timer for the test has misoperated, even though it's not actually connected or to the horizontal coupling plane, but it's enough of a discharge to interfere with that clock. And that's completes the test. Now let's power cycle the bolt. We can see that the bolt is still recording given the LED operation, but I'm going to power cycle the bolt and make sure that it comes back up correctly. So I'll remove the voltage cable, and the bolt will continue to run on its supercapacitors for a bit. We're going to let that discharge. All right, I'm going to apply power to the bolt and let the bolt boot back up. And you can see the bolt go through its boot sequence with the LEDs. And now the bolt is back on the Wi-Fi network. And I will reconnect to the bolt with ProVision. And we have our waveforms back, and the bolt is operating normally. And the bolt is safe from the user, given that it has survived the IEC 61004-2 ESD discharge test.